Welcome to PreMath. In this video, we have got this trapezoid ABCD, as you can see in this diagram, such that its side length AB is 1 plus square root of 3 units, whereas this other side length BC is 2 units, and these angles are 90 degrees each. And furthermore, this side AD equals to this side CD. And now our task is to calculate the area of this trapezoid ABCD. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our next step. We have dropped this perpendicular CE on this side AB, as you can see. And now let's focus on this square AECD. Let's assume that this side length of the square is x, then all these side lengths are going to be x across the board. And now our task is to solve for this x value. And now let's make an observation. We can see that this whole length AB is 1 plus square root of 3, and this AE length is x. Therefore, this remaining segment EB length is going to be 1 plus square root of 3 minus x. And now let's focus on this right triangle BEC. And we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is 2. And our two other legs are x and this 1 plus square root of 3 minus x. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got x square plus 1 plus square root of 3 minus x whole square equal to 2 square. And now let's focus on this part on the left hand side. And here I have copied it down. And now let's recall this famous identity: a minus b whole square could be written as a square minus 2ab plus b square. And here in our case, this part is our a and this part is our b. So therefore, this could be written as 1 plus square root of 3 whole square minus 2 times x times 1 plus square root of 3 and then plus x square. And now we can see that this whole square turns out to be this one. As you can see in this next step, I have replaced this whole thing by this part. And now we are going to combine these like terms. And on the right hand side, 2 square is going to be equal to 4. And now let's focus on this part on the left hand side. And here I have copied it down over here. And now let's recall once again another identity: a plus b whole square could be written as a square plus 2ab plus b square. So in this case, this is our a and this is our b. So therefore, this could be written as 1 square plus 2 times 1 times square root of 3 and then plus square root of 3 whole square. Let's simplify. That's going to give us 1 plus 2 times square root of 3 plus 3. Let's add these two numbers. So that is going to give us 4 plus 2 times square root of 3. And now we can see this 1 plus square root of 3 whole square turns out to be equal to 4 plus 2 times square root of 3. As you can see in this next step, I have replaced this whole thing by this one. And now we can see this 4 and this 4 on the right hand side, they cancel each other out. So therefore we are ended up with the 2x square plus 2 times square root of 3 minus 2 times x times 1 plus square root of 3 equal to 0. We can see all these terms are divisible by 2 across the board. So I divided each and every term by 2. So therefore we are going to get x square plus square root of 3, and here we got minus x times 1 plus square root of 3 equals to 0. And now we are going to distribute x. So therefore we ended up with the x square plus square root of 3 minus x times square root of 3 equal to 0. And now I'm going to rearrange them. I can write x square minus x times square root of 3 plus square root of 3 equals to 0. And now let's focus on this equation. We can see x is in common between first two terms, and minus square root of 3 is common between them. So therefore I can factor out x. So we got x minus 1, and here I'm going to factor out negative square root of 3. So we got x minus 1 equals to 0. And now we can see x minus 1 and x minus 1 are in common. So therefore we got x minus 1 times x minus square root of 3 turns out to be equal to 0. And now we are going to separate these two factors. So we are going to get x minus 1 equal to 0, and the other one is x minus square root of 3 equal to 0. For this first equation, our x value turns out to be positive 1, and for this second equation, our x value turns out to be square root of 3. So thus we are ended up with two values of x equal to 1, and the other x value is square root of 3. And here's our next step. We are going to consider the very first scenario when x value is 1. In other words, all these x values are going to be 1 over here. And furthermore, this segment AB is going to be this 1 plus square root of 3, and our x value is minus 1. And here we can see negative 1 and positive 1, they are gone. So therefore this segment EB turns out to be square root of 3. And now let's make an observation. We can see the area of this trapezoid ABCD is going to be equal to the area of the square AECD. We are talking about this square area plus the area of this triangle BEC. We are talking about this triangle BEC area. So therefore now our task is to calculate the area of this square, and likewise we're going to calculate the area of this triangle BEC as well. And now let's go ahead and calculate the area of this square AECD. And now let's recall the area of a square formula, area equal to s square, where s is the side length, and in our case the side length of this square is 1. So therefore this area AECD is going to be 1 square, that is going to be equal to 1. And now let's focus on this triangle BEC. We are going to calculate the area of this triangle. And now let's recall the area of triangle formula, area equals to a half times base times height. And in our case the base of this triangle is square root of 3 and the height is 1. So therefore the area of this triangle BEC is going to be a half times square root of 3 times 1. Let's simplify. That is going to give us square root of 3 divided by 2. And now let's recall this equation once again. We already figured out our square area and the area of the triangle as well. So therefore let's go ahead and fill in the blanks. So we got 1 plus square root of 3 divided by 2. So therefore for this first scenario when x equal to 1, our trapezoid area turns out to be 1 plus square root of 3 divided by 2 square units. And that is going to be approximately equal to 1.866 square units as well. And here's our second scenario when x value is square root of 3. So therefore this x value is going to be square root of 3, square root of 3, square root of 3, and likewise square root of 3 over here. And furthermore for this segment I'm going to substitute this x value as square root of 3 over here. So therefore this is going to become 1 plus square root of 3 minus square root of 3, and here we can see they are gone. So therefore this EB segment turns out to be 1 unit. And now let's recall this equation once again. We are going to calculate this square area and the area of this triangle BEC as well. So therefore the area of this square AECD is going to be square root of 3 whole square, since the side length of the square is square root of 3. And if we simplify, that is going to give us 3. And now we are going to calculate the area of the triangle BEC. This is our base and this is our height. So therefore I can write a half times 1 times square root of 3. Let's simplify. That is going to give us square root of 3 divided by 2. And now let's recall this equation once again. We already figured out our square area as 3 and this triangle BEC area as square root of 3 divided by 2. So let's go ahead and fill in the blanks in this equation. So we got 3 plus square root of 3 divided by 2. So thus for our second scenario, when x value is square root of 3, our trapezoid area turns out to be 3 plus square root of 3 divided by 2 square units. And that is going to be approximately equal to 3.866 square units as well. So thus we are ended up with 2 sets of solutions. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.